Fire away. Anyone? I can't see you, so you probably just have to yell it out or something.
Hi, Elon.
Yes, there's 6 Raptors on Starship. Currently 3 with the vacuum nozzle, 3 sea level. Sorry?
Check.
And I think if I would say, like, we'll probably end up adding another 3 vacuum engines. They kind of, fill in the gaps and stretch the ship. I think is going to make a lot of sense. You'll have to yell, unfortunately. We are building a launch site, a Starship launch tower at 39A at Cape Kennedy. And we're also building a Starship production facility at the Cape. So we'll have production facility and launch site here and a production facility and launch site at the Cape as well. It's important to have redundancy.
Hi,
Sorry.
Elon. It's Irene Klotz with Aviation Week over here.
I've got lights in my eyes, so unfortunately I can't see.
Okay, well,
I'm blinded. So I can hear where the speaker is coming from.
Okay.
But,
you should. I believe you're expecting to hear in a couple weeks about the possible finding of no significant impact from the FAA. Have you gotten any indications if that's going to come through, and what is your time frame for the orbital flight test? Thanks.
well, we don't have a ton of insight into where things stand with the FAA. We have gotten sort of a rough indication that there may be an approval in March, but that's all we know.
So, hi, Elon. Marcus Hervey. Can you talk about the point-to-point capability? Is there a possibility between here and Cape Canaveral?
Oh, well, yeah, I guess technically yes. So, I mean, depending on how good things get with Starship, there are some scenarios where it might actually be the lowest cost means of transporting cargo long distances. So the interesting thing is that the capital efficiency of a rocket is much better than the capital efficiency of a plane for long distance flights. So now this would really be more for if you're going like, I don't know, a quarter or a third or halfway around the world, where if you went from, I don't know, say here to Singapore or something, like that's a long flight. So, I mean, I don't know how long that is. I'm not sure you can even go there nonstop, but it's probably like 20 hours plus. And, but in a rocket, it would be less than an hour. So like 45 minutes or thereabouts. So that means you'd be able to use the rocket 20 times more often than an aircraft. So it's 20 times the capital efficiency. So provided the propellant cost is competitive with aircraft. And bear in mind, like I was saying, there's 3.5 tons of liquid oxygen for every 1 ton of fuel. And liquid oxygen is basically just the cost of electricity. Because it's in the air, basically. There is a scenario where it's economically compelling to do long-distance cargo and people transport with Starship. That'd be very cool, and I think that'd be great for getting a high flight rate and a business case for supporting a lot of Starships operating. And basically, nothing's faster than an ICE EVM.
We got a question right here, Elon, right in the middle, right here, right, hands up in the middle.
I mean, I literally have lights in my eyes, and it's pitch dark in front of me.
It's fine. Hi, Elon. Michael Sheets with CNBC.
You opened this presentation by addressing a little bit of the criticism that's been aimed at space travel being seen as maybe a pet project or not really valuable to folks who have problems here on Earth. I was wondering if you could get a little more into the specifics on comparing not just the U.S. government spending that's happening on space travel versus other things, but maybe in terms of SpaceX itself, how you and private investment on a dollar value compares to the taxpayer-funded projects or contracts that SpaceX has won over the years.
Well, I think objectively, the cost efficiency of SpaceX is the best in history, I think, for any rocket development, and we are talking about a rocket that's more than twice the mass and thrust of a Saturn V, and also designed to be fully reusable, which is obviously also much better from an environmental standpoint to have a fully reusable rocket, for a development cost that is, I don't know, between 5 and 10% of Saturn V. So that's pretty good. Of course, we need to make it work, so it's not worked yet, but it will work. Might be a few bumps along the road, but it'll work. I feel at this point, highly confident that we'll get to orbit this year. That's we're making a lot of rockets, making a lot of engines. We're close to achieving a Raptor 2 every day production rate, so 7 a week, which is tough for a complex engine. And I think by the end of this year, we'll be able to produce a ship and a booster per month. So this is I don't know, at least an order of magnitude, maybe 2 orders of magnitude more efficient than anything in the past. Yeah. So.
Hey, Elon, this is Joey Roulette for Supercluster. Just wondering, what does SpaceX's plan and timeline look like if the FAA ultimately decides to do a deeper environmental review of Starbase? And then one other thing, you might be able to give us an updated figure on what it costs to Starship and what it would cost a customer to buy a flight on one. Thanks.
Yeah, I mean, I am optimistic that we will get approval. Like I think objectively, I think this is not something that will be harmful to the environment. We've obviously flown the ship several times and done multiple landings and takeoffs and landings, and we've fired the engines a lot. So I think the reality is that it would not have a significant impact. Now, of course, that doesn't mean things don't get delayed from a regulatory standpoint. And we are in a litigious society, and so there's always sort of lawsuits from someone, lawsuit city. Now we do have the alternative of the Cape, and we actually applied for environmental approval for launch from the Cape a few years ago and received it. So we actually are approved from an environmental standpoint to launch from 39A. So I guess our worst case scenario is that we would, I don't know, be delayed for 6 to 8 months to build up the Cape launch tower and launch from there. From a cost standpoint, the costs will improve significantly over time. So because it'll take us a moment to achieve full reusability and full and rapid reusability, we'll probably lose a few vehicles along the way. With Falcon 9, I think it took us 14 or 15 attempts to successfully land the first booster. I don't think it'll take us that many with Starship because we have that experience, but it's certainly not a sure thing that it'll work the first time. I mean, from a cost standpoint, I mean, it's a 100-ton capability to orbit. On a marginal cost to launch basis, that doesn't count fixed costs, which obviously have to be covered. It may be as little as a few $1,000,000 per flight, maybe even as low as $1 million per flight. So this is crazy. These are crazy low numbers by space standards, crazy low. Now, we do have to cover fixed costs, so depending on what our launch rate is, we have to divide the fixed cost by the number of launches. So the more launches that happen, the lower the total cost, fully considered cost per flight would be. But I'm highly confident it would be less than $10 million all in over, if you say like fast forward like 2 or 3 years from now. I think it's highly likely to be everything included less than $10 million a flight for 100-ton to orbit capability. And 100 tons to a useful orbit, not to a low orbit. To a low orbit, it would be 150 tons. So this is ridiculously good compared to everything else. And it should be, because if you think of like, if this was if aircraft were not reusable, how much would an air ticket cost? I mean, it's like, for, I don't know what, a 787 or 777 goes for these days. I don't know, a few $100 million. If you had to spend, $200 million every flight, it would be very expensive to fly somewhere, and you'd need 2 of them for, another one for the return trip. So, it would obviously be absurd. So if you can imagine if we were in a world where aircraft were expendable, and then someone came along with a reusable aircraft, it would be an absolutely profound game changer. That's what needs to happen for life to become multiplanetary, and that's what this design, I'm confident, is capable of that. It's just a question of how long it will take to refine that and have it really dialed.
Hi.
Hi.
Sorry, this is Andrea Leinfelder of the Houston Chronicle. I wanted to know, when and how do you plan to test Starship refueling in space? And also, aside from NASA, Dear Moon, and Starlink, can you elaborate on the potential customer base for Starship? Thank you.
I apologize. I zoned out for a second. I was just thinking about something. Could you say that question again?
Sorry. When and
We have some mic issues. But.
Okay. When and how do you plan to test Starship refueling in
Oh,
space?
yeah.
And aside from NASA, Dear Moon, and Starlink, can you elaborate on potential customers for Starship? Thank you.
I think orbital refilling, and I want to emphasize it is refilling, not refueling, because it's 3.5 times as much oxygen than fuel. So we mostly are carrying oxygen up there. I optimistically, towards the end of next year, I think I'd be surprised if it's longer than 2 years for doing the refilling. And there are a lot of additional customers that will want to use Starship. I don't want to steal their thunder. They're going to make their announcements, and but I think this will get a lot of use, a lot of attention. It's like I said, once we make this work, it's an utterly profound breakthrough in access to orbit. And when you have an utterly profound breakthrough, the use cases will be hard to imagine. I mean, when aircraft first came along, aircraft were viewed as toys, like they were like a novelty, not a means of transport. They were like, oh look, we can fly like a bird briefly and dangerously for a few minutes. Nobody at the time, or at least I think very few people at the time, thought that there would be a global aircraft industry with airports throughout the world carrying people to every part of Earth in ridiculously short periods of time. You know, when the Wright brothers first took off, I mean, most people were just riding horses. So you're like, oh, you know, like riding a horse, see this crazy device, looks like witchcraft. And they would not have imagined that there would be aircraft flying, you know, tens of thousands of aircraft flying to every corner of the world. So I think we made this really could be an extremely profound situation, and we really can't even imagine all the use cases at this point. So.
Hi, Elon. This is Steve Clark with the Brownsville Herald. Thank you for the presentation.
You're welcome.
So if the FAA does come back and say we need an EIS, does Starbase bounce back from that at some point?
Yeah, I mean, it would obviously set us back for quite some time because an EIS takes a lot longer than an EA. So we would have to shift our priorities to Cape Kennedy.
Okay, and long term, what do you envision for Starbase? Like a spaceport with flights coming and going and Starship manufacturing, or what is the future role of Starbase?
The future role of Starbase, I think, it's well suited to be kind of like our advanced R&D location. So it's like where we would try out new designs and new versions of the rocket, and then I think probably Cape Kennedy would be our sort of main operational launch site, and then. I don't know, over time, I think there's going to be, we'll have floating spaceports, like ocean spaceports. We got these 2 converted oil rigs that are going to be turned into orbital launch sites. And they can be moved around the world. So, you know, that I think there could be quite a few of those. You know, I think about like, if I think about like, what would really work for long distance travel. Because the rocket is quite loud, you want to be, you know, I don't know, 20 miles away from a major city or 30 miles away from a major city, just so you don't, you know, not you know, disturbing people too much. So I think probably most of the launch sites long term will be kind of ocean or sea spaceports. So like maybe located like 20 miles, 30 miles offshore. And this would allow Starship to connect any cities that are on the ocean or on the sea, and have a high flight rate, but without disturbing people too much. You know, I think people are willing to, you know, have something that's loud occasionally, but if you want to have it frequently, then it probably needs to be offshore.
Hello, Elon. I'm Cam Gerlach with the SpaceX Reddit community. So you've talked a lot about how Raptor 2 is crucially important for Starship development and for the future of Starship. So I'm curious, what general improvements have you made with Raptor 2 to ensure it's not only more efficient and more powerful, but also much easier to produce and less expensive as well and faster? And how do you plan to continue to iterate further on the design in the future?
So, Raptor 2 is an almost complete redesign relative to Raptor 1. So basically everything from the turbomachinery to the chamber, nozzle, the electronics, basically everything's been redesigned. You can see the difference over there, the Raptor 1 versus Raptor 2. You know, a lot of the changes were deleting things. We deleted a lot, consolidated a lot. The rotating machinery, especially the inducers of the turbopumps, are a lot more robust. we converted a bunch of flanges to welds, and we're actually over time will convert even more flanges to welds. I hate flanges, especially if you've got high pressure and a cryogenic fluid or super hot gas. Flanges and seals are a nightmare, and so we've got parts of that engine that are sort of 700-800 bar, sort of 11, 12,000 psi, which is nutty, and so just going to welded joints instead of flanges was pretty helpful. The pre-burner controllers have been consolidated into a sort of a unified box as opposed to being kind of like all over the engine. And we're getting close to the point where I think Raptor will not need shrouds. So shrouds are a huge pain in the ass, like basically putting a whole shield around the engine, especially for the gimbaling engines, where it's got to kind of have like a sort of eyeball seal, like it's like rotating in a circle with a hot gas seal. With a bit more deletion and integration, I think the engine will be sort of flame proof, more or less, and then we can get rid of the shrouds, which would be a big mass savings. Yeah. So a lot more could go on. We're also operating at a higher chamber pressure. I think we can probably operate. I think over time we can operate it at 330 bar sustained in the main chamber, without having the pre-burner pressures be too high, by essentially not by losing less pressure. There's like a whole pressure ladder going from the turbo pumps and pre-burners to the main chamber, and by getting rid of a bunch of the choke points, we can have less pressure loss, and so the pumps can effectively produce more pressure in the main chamber due to less loss in the secondary systems. Do you have any? Have specific questions or?
Sorry, Chris Gephardt with NASA Spaceflight. Can you talk a little bit about the abort modes that are available for ship if there were ever to be a problem during the climb to orbit? What would be available to the crew in that regard? And also on that same level, the life support systems for ship. Where do those stand, and what are the challenges that you're finding with just the sheer volume in Starship for that? Thank you.
So Starship will not have an independent abort system, but I think something that would make sense is to have the thruster weight of the ship be enough that it could do it could take off from the booster, even if the booster has a failure at the pad level. So if you can get the thruster weight of the ship at sea level above 1, then even if there is something goes wrong with the booster, the ship can essentially fly away from the booster. And so that's something that I think would be important for carrying people, and also for high-value cargo, to have the ship have a thruster weight greater than 1 even at sea level. And then there's like I said, that would be like the 9-engine version. And then even if you lost one engine, I think you should still be able to do an abort. So I think for crewed missions, we would essentially maybe detank the ship to some degree so that you'd have kind of a launch abort capability with the ship, even if you lost an engine. That'd be my recommendation. From a life support standpoint, we would have a sort of a renewable, like for long, we could scale up the life support system in Dragon. That would certainly be an option, and that would work for missions that are, say, a week or 2 weeks. That would be fine. For missions to Mars, you'd want a life support system that is renewable. So it's essentially recycling everything in a closed loop system with close to zero loss to mass. So that would be a more advanced system, because you'd have to convert the CO2 back into O2 and kind of recycle, poop and urine and stuff. Yeah. So that's a harder problem, but it's not an immediate problem. We can certainly scale up Dragon for any kind of missions that are, a few weeks long.
Hi, Elon. Eric Berger with Ars Technica. Thanks for taking some questions. I'm wondering if you do get that approval from the FAA in March. I know that there's really no way of knowing, but could you talk a little bit about the hardware readiness, sort of where you are technically? The launch tower is pretty incredible, but sort of the rocket, the ground systems, software. Like if you were to get some kind of approval from the FAA in March, would you be looking at, how quickly could the hardware be ready to go?
Yeah, I mean, I think we're close to having the hardware ready to go. So right now, I think we're tracking to have the regulatory approval and hardware readiness around the same time. Yeah, so yeah, around the same. Hopefully, basically a couple months for both. Yeah.
Hi, Seth Krakowski with spaceexport.com. You mentioned launching from the sea. Could you give us an update on the current status of using Phobos and Deimos for Starship operations?
Yeah, so Phobos and Deimos thus far have been a relatively low priority. We needed to make the launch site here work. This has been quite a difficult endeavor. So we deprioritized the Phobos and Deimos. And just last month, we started to, we're going to take one of them and build at least a catch tower on it. So, and ultimately we will, ultimately meaning like, I don't know, later this year, build a full launch capability on one of the platforms. So I think hopefully by the end of this year we will have a launch capability at Cape Kennedy at 39A and on one of the ocean platforms as well.
Hi, Ellen. This is Adam Cardona with CBS 4 and NBC 23 here in the Rio Grande Valley. This is more of a community-based question. This past week, several BISD students, community leaders, and community members got together to ask you a question and to show their gratitude. Not sure if you got that message yet, but they were saying thank you, Elon, and they wanted to know if you would be able to attend their Chatos Days festivities here in Brownsville. So on behalf of them, will you be attending Chato Days?
It sounds like fun. So like, when is it?
I believe it starts on the 19th through the 25th. So you have several days to attend Sombrero Festival, Chato Days parades, enjoy some great food. Will we see you there?
I will be there.
All right.
Yeah.
That's going to be hard to follow up. Hey, Elon. Tim Dodd, the Everyday Astronaut here. Okay, so a little bit more Raptor 2 talk again. Where are you at as far as production? How many do you have? Are they handling, testing? Are they more cantankerous, less cantankerous? Just give us a little more rundown, like on where you're actually at. Is that a bottleneck for the next booster as well? We assume the next booster is going to require, Raptor 2. So, kind of where are you at with the production and the testing so far?
Well, I mean, right now, of any technical problem, I'm spending the most time personally on Raptor 2. Like really, they're like the two things that occupy the most number of mental cycles are Raptor 2 and Tesla Full Self-Driving. So the only remaining issue that we're aware of is melting the chamber. So that thing really wants to melt, It's got like on the order of a gigawatt of heat, so it's pretty hot. Like a gigawatt's like what a nuclear power plant produces. So it really is desperately trying to melt at any point in time. We've got, we're flowing an immense amount of cryogenic fuel to cool the chamber in the channels. We have head-end film cooling. We've got throat film cooling. And we're just trying to get the exact sort of balance between head-end film cooling and throat film cooling to not melt the chamber. I think we're pretty close. Like we have a couple engines in the stand that have I think 700 or 800 seconds of operation and several start cycles. So it's looking positive, but that's the remaining issue is melting the chamber. But in the meantime, we're scaling up old production to get to 1 a day or better. So apart from melted chambers, we're doing well. We've got a lot of pumps, a lot of electronics, a lot of pre-burner controllers. Just not melting the chamber, which is very difficult, is the kind of the last remaining challenge. But I think we're very close to solving that. And then the production system has a lot of momentum. Like I said, we're really, like next week we'll probably make at least 5 or 6 Raptor 2s, for example. Yeah. And I think we'll be at a 7 a week or better by next month. But those are crazy. These are crazy numbers for rocket engines, by the way. Yeah.
Hi, Elon. Robert Perlman with Space.com and Collect Space. You mentioned the NASA contract for the human landing system. At one point, do you envision splintering off development of Starship for HLS, or how are you going to balance the timelines of rapid reusability versus NASA's own schedule of when they're ready to go to the moon?
I don't think there's really a conflict there. We're going to be making a lot of ships, a lot of boosters, obviously a lot of engines. Yeah, it's kind of interesting. Like with the booster with 33 engines and the ship with 9 engines is 42. There we go again. And that also total coincidence. Adding legs to land on the moon, we do not think is like that can be done pretty quickly. I don't really see any conflict between achieving rapid reusability and getting to the moon. A high production rate solves many ills. So we're aiming for a high production rate.
Hi, Lauren Grush with The Verge. I'm wondering if you can clarify the number of launches that you plan to conduct in order to do these refillings. I know a lot of numbers have been thrown around, so I'm wondering if you have landed on a final number. And how quickly do you plan to launch those missions back-to-back to refuel the vehicle to get to the moon? Thanks.
Yeah, so the missions would happen pretty fast for refilling the vehicles to minimize boil off of the cryogenic propellants. Now for the vehicle going to the moon, we have some installation to minimize boil off. But we'd probably be launching, I don't know, probably every few hours. Aspirationally. So, yeah.
Hi, Elon. Kevin Haymeyer from Space Eccentric on YouTube and Rumble. Thank you. My viewers are really hungry to know anything about the interior design for crewed Starship. You have HLS, you have Dear Moon. And last we heard, maybe a year or two ago, you were looking to hire Tesla employees to design the interior for Starship. How's that going?
Well, we aren't focusing a lot on the interior quite yet. I mean, that will be important down the road, but our focus right now is just getting to orbit and proving out return of the booster and return of the ship. Yeah, it's fundamentally very difficult to build a fully reusable rocket given the strength of Earth's gravity and the density of our atmosphere. Like there's no, you can't have a lot of mass margin. So our focus is solving that rapid reusability. Like I said, we'll have a high production rate, so we're not dependent on we're not dependent on full reusability, but really that's the breakthrough that's fundamentally important to change the course of human civilization to become a multi-planet species.
Elon, this will be the last question for you.
Evening, Elon. Bob Duncan. I'm a local resident.
We're cutting out the mic.
Are we cutting out? Is that better? Hi, evening. My name is Bob Duncan. I'm a local resident here in the area. And first off, thank you for a very cool evening. So this has been a lot of fun for us. As a local resident, it's been exciting to watch the amazing progress that SpaceX has made here in Boca Chica. And I was just curious, we're standing on the southern tip of the state of Texas. We're a few hundred yards from your residence. Could you just speak to what, if anything, has been appealing or advantageous about operating in the state of Texas versus other parts of the country? Thank you.
Well, I think we've, well, I mean, we've had a lot of support from the community, and something that just happens over time with societies is that kind of rules and regulations build up, and they build up, more in some places than others, and they didn't, I think Texas has the right amount of rules and regulations. Yeah.